Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over problems 6 to 10 of our Next Generation Accuplacer Volume 2 review series, focusing on arithmetic. Don't forget there are 5 practice problems at the end of this presentation that we'd like you to try out in order to demonstrate mastery of what we covered in this review series. If you'd like to gain access to our entire playlist and other valuable resources, just take a look at the link in the description below, or you can visit our website at mathgotserved.com. Alrighty, let's take a look at question number 1. In question 1, we're being assessed on how to order a combination of fractions and decimals. This is a typical question that you should expect to see on the Accuplacer test. Now, there's a tip that you want to keep in mind when you are asked to order fractions and decimal. And the tip is as follows. When comparing or ordering, when comparing fractions and decimals, the best strategy, ladies and gentlemen, is to convert all of them to fractions or all to decimals. Okay? Express all the numbers as fractions only or decimals only. Basically convert them to the same form. Okay? In some problems, it's easier to convert them to fractions. In others, it's easier to convert them to decimals. In most cases, personally, I think converting everything to decimals is pretty straightforward. In this particular scenario right here, the best thing to do will be to convert the fractions into decimals. You see why that's the case in a minute. Okay? All right, so let's go ahead and do it. So what we're going to do in this particular problem is we're going to convert fractions to decimals. All right. Now the thing about converting everything to fractions is that after you convert everything to fraction, you have to ensure that you have the denominators identical. Okay, so you convert to fractions and then you find the LCD and express every single number as an equivalent fraction, with all your denominators being identical, which could be a long process. Okay, all right, so let's go ahead and convert our fractions to decimals. We have two fractions here. First one is 9 over 8. So if we want to convert 9 over 8 to decimals, how do we do it? Well, we use long division, right? So set up our long division bar. The top dog goes in the dog house. The numerator goes underneath your division bar, and you have the 8 on the outside. Okay, let's divide. How many times does 8 go into 9? 8 goes into 9 once. 1 times 8 is 8. Subtract. You have 1. All right. Now, how many times does 8 go into 1? 8 is bigger than 1, so 8 can go into 1. So put a decimal point here and add a 0. How many times does 8 go into 10? 8 goes into 10 once. 1 times 8 is 8. Subtract 2. Add a 0. How many times does 8 go into 20? 8 goes into 20 twice. 2 times 8, 16. 4. Add a 0. How many times does 8 go into 40? 5 times. 5 times 8, 40. All right, so 9.8 is equivalent to 1.125. All right, let's move on. Let's convert 11 over 4 into fractions. Into decimal. Now for the problem I just did, 8 over 9, you didn't have to do everything. You didn't have to do the entire division problem, okay? So we're comparing it to these two numbers, and you see that this number here, 3.71, the whole number part of it, the number that's greater than 0, is bigger than 1. So just after the first step, you automatically know that this is smaller, okay, because we're looking for the greatest. So you know that 9 over 8 is smaller than 3.71. So you didn't have to do the whole thing, but I just wanted to do a real quick review on long division for you, okay? All right, so let's do it here. 11 over 4 Top dog goes in the doghouse. Put the 4 here. How many times does 4 go into 11? 4 goes into 11 2 times, okay? So we have 2 times 4 is 8, and you can automatically see that this number, 11 over 4, is smaller than 3.71, okay? But let's just finish it anyway. So 2 times 4 is 8, we have a 3. How many times is 3? Does 4 go into 3? It's too small, so we put a decimal point and add a 0. All right, now how many times does 4 go into 30? 7 times. 7 times 4 is 28. Subtract that, you have a 2. How many times? Well, put a 0 here. How many times does 4 go into 20? 5 times. 5 times 4 is 20. Subtract to get a 0. Okay? All right, so 11 over 4 is 2.75. So what I'm going to do now is I'm going to order these numbers from least to greatest. Okay, so the smallest is clearly 0.97. 0.97 is less than, now which one comes next? 9 over 8. And then followed by 2.75. And then the biggest is 3.71. Okay, so which of the number is the greatest? The greatest number is 3.71. Alrighty, so that's how you order a combination of decimals and fractions. Alrighty, let's take a look at problem 7. In question 7, we're being assessed on how to calculate the amount resulting from taking a percent off. Problem 7 reads, if Jeff deposits 40% of 170 into a savings account, what is the amount of his deposit? Alright, so we're going to use this problem as an opportunity to review 2 important formulas that you need to know concerning percentages. Okay? Alright, one thing to keep in mind is that we have our collection of must-know Accuplacer formulas on our website at mathgotserved.com. So if you would like to gain access to those formulas to review, just visit our website or take a look at the link in the description below for videos related to those formulas. Now, we covered this particular formula in part 1 of this review series, volume 2 and 3, which is how to find percent of a whole. Okay, so the percent of the whole is basically the part divided by whole times 100. So you might have seen this formula in our previous series. Now, we can carry out some algebraic manipulations to this formula to derive the formula that we need for this particular problem, which is the part, okay? Part of the whole. So how do we get that part isolated? In order to get that part, which is the amount resulting from the percent of isolated, we can basically get rid of this 100 and this whole on the right side of the equation. So to do that, we just simply multiply by whole on both sides. While we're multiplying by whole, well, the opposite of divide is what? Multiply. So since you're dividing by a whole, if you multiply by whole, it's going to cancel out the whole. Okay? And then you have times 100, guess what? We are going to divide by 100. Alrighty? So what we're doing right now is just deriving another formula that you need to know to calculate the part after a percent is taken off the whole. Okay? Alright, so let's see. What do we have here? Let's see, I haven't used black yet. The wholes cancel out. And then 100s cancel out. And then you end up with this important formula. Formula 2, the part is equal to the percentage of whole, or percent of divided by 100 multiplied by the whole. All right, so that's the amount that percent of represents, okay? All right, so let's go ahead and do it. So the part that's deposited in the savings account is given by the percent that this part represents, which is 40%, We divide that by 100. Now let's freeze for a second. What do you accomplish by dividing 40% by 100? Well, this represents the fractional part that this part represents, okay? So it's a fraction. So to get the exact amount, we're going to have to multiply this by the whole, okay? Fraction of the whole is $170. So let's go ahead and carry out our calculations. So we can cross reduce, divide by 10, 10 goes here 1, 10 goes here 1. Divide by 10 again, 10 goes here 1, 10 goes here 1. So you can see the division trick here. When you divide by 10, you just cancel out a 0 from a numerator and the denominator, okay, of the numbers you are trying to reduce. So now we're going to go ahead and multiply our resulting fraction, which is 4 times 17. What is 4 times 17? That's 28 plus 40, which is 68. Okay, $68. So 40% of $170 is $68. Let's just write that down so you can understand exactly what just happened. So 40%, the percent of the whole $170 is the amount. What's the amount? $68. Ladies and gentlemen, the answer to question number 7 is option letter C. Okay, now some of you are really good with percent to decimal conversion. So if you are good with that, another way that you can do this problem is if you're told 40%, you can convert that to decimal. So let me put another method here, method 2. All right, slightly more advanced. So you say 40% of 170, right? So if you know that 40% in decimal form is equivalent to 0.4, off represents the operation times 170, okay? And then you just multiply this. So you have 170 times 4.4, right? And then you have 4 times 0 is 0, 4 times 7, 28, 82, 4 plus 2, 6. Okay. And then the decimal point is right here. And then you get $68. So this is a faster way of doing it. If you're comfortable converting percent to decimal mentally, and then you just carry out your multiplication. It's exactly the same thing, but a slightly faster and more advanced approach to carrying out calculations of this nature. Alrighty, let's take a look at problem number 8. In this particular problem, you're going to be assessed on how to add whole numbers. Okay, in this particular example, we're looking at the arithmetic of adding a 4-digit number with a 3-digit number. So, what is something to keep in mind to avoid making mistakes? When you're combining, adding or subtracting multi-digit integers or whole numbers, this is what you always want to recall. A good strategy is as follows. We're going to apply this to another problem shortly, you will see. You want to align the digits vertically by identical place values. Okay, so align the digits vertically by identical place values when adding and subtracting. Okay, all right, so let's do it. So we have 2,561. So 783, this is 100 tens and ones place, right? So you want to put the 7 right underneath the 5, 8, 3. You see the importance of what we're talking about. Make sure that they're aligned vertically by identical place values so you do not make any errors with your computation. All right, so what we're looking for here is the sum. So let's go ahead and add it up. 1 plus 3 is 4. 6 plus 4 is 14. 4 carry 1. Then we have 6 plus 7. 3. Oh, snap, computer's not working. So we have a 3. And then a 3. Okay? So it's 3,344. The answer to question number 8 is option letter B. Alrighty, let's take a look at question number 9. On question 9, we've been assessed on how to divide integers presented in a word problems setting. Okay, problem 9 reads, Sonny Wu is making a cake. Each cake uses 4 eggs. If Sonny Wu has 25 eggs, and assuming he has enough of the other ingredients to make the cakes, what is the greatest number of cakes he can make? Okay, so in this problem, we're going to start by writing down the formula that will guide our problem solving process. All right, so we're going to use a derivation approach again, like we did in the previous problem. We're going to start with the formula that we covered in the previous presentation, part 1 of this series, okay, which is how to find the total amount. So the total amount is basically given by the number per unit if you remember this particular problem, multiplied by the number of units. Okay? All right, so this is one of the formulas that you need to know to do well on your test, okay? All right, so what we're going to do here is in this particular problem, we are looking for the number of units or the number of cakes. The units in this particular problem is cakes. We're trying to look at the number of cakes that can be made. All right, and we're given the total amount of eggs that we have and the number of eggs per cake that can be used. Okay, so how many cakes can be made? So what we're going to do, since we're looking for a number of units here, what can I do to this formula to get number per unit? To get number of units, number of cakes isolated. To get number of units isolated, what we're going to do is eliminate number per unit. Okay, so I'm going to divide both sides of my equation by number per unit. All right, just like in this case, we have 4 eggs per cake, right? So that's a number per unit. So divide both sides by number per unit. And that will take us to another formula that you need to know to do well on your test. Okay, the formula is as follows. So here what's going to happen is that the number per unit will divide out and you end up with the formula number of units is equal to the total amount divided by the number per unit. That's exactly what we want for this problem. Alrighty, so let's go ahead and adapt this problem to this particular formula that we have here. So the number of eggs, let's change colors. So the number of eggs, number of cakes. The number of cakes that can be made is equal to the total number of eggs, divided by what? The number of eggs per cake. Okay, divided by number of eggs per cake. Okay, so let's go ahead and work it out. Total number of eggs is, what was it? 25. And then we divide that by number of eggs per cake, which is 4. Okay, so what is 25 divided by 4? 25 divided by 4 is 6 1/4. So what does that tell us? We can make 6 whole cakes. All right, and then this 1/4 cake here, that doesn't count. The question asks for the greatest number of complete cakes that can be made, and the answer is going to be option letter B. Now, why can't we say 7? We can't say 7 because you do not have enough eggs to make the last one. Okay, you have one more egg. You have the first 24 eggs can be used for the 6 cakes, and then you're left with one more egg, and you cannot make another cake with that. That is why you just round down. Okay, in scenarios like this, you're gonna round down, and the answer is option letter B. Okay, question number 10. In this problem, we're going to be looking at how to add decimals. Okay, this is an extension that is very similar to the skill that was assessed in question number 8 on how to add integers, multi-digit integers. Remember, we added a 4-digit integer with a 3-digit integer. Well, now we're dealing with decimals, but the same principle applies. Okay, do you remember what the guideline was? Something that you wanted to keep in mind? Well, let's go over it again. So it's similar to the other problem that we did. So the tip is as follows. When adding, subtracting, even multiplying, or multiplying decimals, guess what? Alignment is very important. Okay, you want to align all the decimal points vertically first. And then when adding or subtracting, you can insert the placeholder 0. Insert the placeholder 0 where applicable. Okay? Alright, so let's see how we can apply this tip to this particular problem. So we have 3 decimals that we're adding together. Alright? So we have 4.72. So this is the ones place, this is the tenth and hundredth. 0.09, the 9 is in the thousandths place. So you have to put 0.009. Now, since we have a digit in the thousandths place, for the second number, guess what? We'll put a 0 right here. That's the placeholder. That's what we're talking about here. Okay? And then the next one is 0.135. So when you align the decimal points vertically, it's easy for you to carry out your addition, subtraction, and multiplication with a high degree of accuracy. Okay. All right, let's go ahead and add it. 0.9 plus 5 is 14. 4 carry 1. 1, 2, 3. 3 plus 3 is 6. 7 plus 1 is 8. 4 plus 0 plus 0 is 4. Answer to question number 10 is 4.864, option letter A. All right, ladies and gentlemen, it's now your turn. It's your time to do some work. Okay, now we have 5 practice problems that we'd like you to try out, problems 6 to 10. So what we'd like you to do at this time, go ahead and pause this video presentation and then try out these 5 problems. When you're done, click on the play button and we will reveal to you what the correct answers are. Welcome back. So hopefully you had a chance to try the problems. The answers are as follows. To number 6, the answer is 10 over 3. That's the greatest. It's 3.3 repeating. It's bigger than everything else. For question number 7, the answer is $22.50, option C. For number 8, the answer is 3,155, option D. And for number 9, the answer is 7. Okay, you get 7 remainder 2, but you truncate that 2 out of this mix since you cannot make a cake with that fractional amount of flour. Okay, and then number 10, the answer for number 10 is 5.961, option letter C. So how well did you do in these 5 practice problems? Well, let us know in the comment section below how well you did. And if you have any questions on any of these problems or any concept on the Accuplacer tests in general, just put it in the comment section below and we'll be more than glad to assist you. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your preparation for the test, to give us a like. Your positive feedback is very valuable to us. Do not forget to subscribe to our channel. We upload videos, math tutorials to our page on a regular basis. So subscribe and stay in the loop. If you have any questions or comments, as indicated earlier, just place it in the comment section below. We have a cool interactive practice test at our website, mathgotserved.com. Do check it out. And also take a look at the link in the description below for access to tons of math resources. Thanks again for watching and have a wonderful day. Goodbye.